Okay, biconditional. Y'all, you guys hear this word bi a lot these days. If something is bi-directional, what does it mean? It goes both ways. So that word bi means it goes both ways. So biconditional means it goes both ways. It means you can read it forwards and it makes sense, or you can read it backwards and it makes sense. But in geometry, biconditional is going to be this. It goes both ways. You can read it hypothesis if and only if conclusion, or you can read it conclusion if and only if hypothesis. It both makes sense. Now, do you see the word if and then in these statements? No. When something becomes biconditional, it loses the word if and then. So there's one magical thing that has to happen, right? You're only going to write on 2 slides today. You're going to write on this slide, and you're going to write on the next slide. The rest of the time, you're just going to speak it into existence. So a biconditional statement is a single true statement that combines a true conditional statement and its true converse. So we talked about truth values yesterday. Y'all remember that? And I said there's 2 ways that true and false can happen. Somebody spelled that out to me. What was it? T F F T. That means the conditional statement is true, the converse is false, the inverse is false, and the contrapositive is true. I said that these have to match and these have to match. Or we said it could be I said that 99% of your projects would look like this. The first one would be true, it would be false, false, true. Or it would be false, true, true, false. Now this statement right here says that the conditional statement is true and the converse is true. So that looks like this. Well, if the first one's true, what does the last one have to be? They have to match. If the second one's true, what does the third one have to be? So there is a way for them to all be true. And when they're all true, we get this thing called a biconditional statement. You can read it forwards and backwards. So this is hard. This is how you get that 10 extra points on your project, by making them all true. The only way to make all of these true is by using a definition. Because definitions are always true, right? So here's an example. You don't have to write this, you just have to look at it. It says, a point is a midpoint if and only if it divides a segment into 2 congruent lines. Does that sound like a definition to you guys? Yes. Right. What is the definition of a midpoint? It cuts a line in half and makes 2 equal pieces. So here's what I'm trying to tell you guys. What does a midpoint do? It cuts a line in half. Well, if I say, hey, a point cuts a line in half, what do you have? A midpoint. So it doesn't matter if I read it forwards or backwards, it means the same thing. If it's hot, you're going to get burned. If you're burned, it was hot. So it's hot if and only if you get burned. Or you get burned if and only if it's hot. It makes sense both ways. So the hard part for you guys is you have to write a conditional statement and tell me if it's true or false. That's what we're going to do. This is the only one you're going to write today, because it's a lot of writing. The only one. So unfortunately, this is a big chunk of what you missed yesterday. Alright? So you're going to get half of it right now. We have two statements. The sum of the measures of two angles is 180, and the two angles are supplementary. I need to make that a conditional statement by adding the word if and then. So, what is the conditional statement?
If the sum of the measures of two angles is 180, then the two angles are supplementary.
Right? If this, then that. If you write it out, it looks like this. That is your conditional statement. It is generated by adding those two words. If the first thing, then the second thing. I know it's a lot of writing. I'm going to give you a little bit of time to work on that. Does that confuse anybody? Okay, that was part of your homework yesterday. Now, an additional layer to the learning, is this true?
Yes.
If two angles make 180, are they supplementary? True. So, achievement unlocked. Because the first statement is true, you have the ability to write the second statement. We have to converse that. We have to switch the hypothesis and conclusion. So what is the converse of that statement?
If the two angles are supplementary, then the sum of measures of the two angles is 180.
So we just switch everything after the word if with everything after the word then. We switch those two things. If two angles are supplementary, then the measure of the two angles is 180 degrees. And then our ultimate goal today, we need to write that as a biconditional statement. Now, this is tough, and it has to have two things. It has to have the word if and only if in it, and it has to make sense in English. You want to give it a shot?
The sum of the measures of two angles is 180 if the two angles are supplementary.
Close. You just said if. Has to be if and only if.
Oh,
See the
okay.
difference?
Yeah.
So how did you piece that together? Did you go off of this up here or something down here? So literally all you're doing is taking your two statements and connecting them with
If and only if.
the sum of the measures of two angles is 180 if and only if the two angles are supplementary. Here's what it looks like. The sum of the measures of two angles is 180 if and only if the two angles are supplementary. So because the conditional statement is true, and because the converse is true, it allows us to write this one. Now, if you wanted to go extra and say two angles are supplementary, if and only if those two angles add up to 180, it still works. It is biconditional. You can read it forwards and backwards. Now, if you want to do this on your project, you can. But your slogan has to be a definition. It has to be true for the conditional statement and the converse. Set your pencil down, please. Simon says, do not write this. I need you guys to speak this mathematics into existence. So it is just see and speak. Points in quadrant 3 have two negative coordinates. You need to make that a conditional statement. You have to add the word if and then. Who wants to try and speak that into existence? Can you do it?
If the points are in quadrant 3, then they have two negative points.
Perfect. I think I wrote it a little different. If points are in quadrant 3, then they have two negative coordinates. I think most of you guys saw that in your mind. You just couldn't verbalize it. Now we have to establish, is that true or is that false?
False.
Shame, shame, shame on your 4th grade math teachers. Why are we so questionable right now? You don't know where quadrant 3 is, do you?
Yeah, it's at the bottom. See if I
How do you remember that? What did your teacher tell you?
she put in parentheses like positive, positive.
Okay. So my teacher back in the day, like let's say back in the 90s when I was in 4th grade, told me this. Deion Sanders, Barry Sanders. What number was Deion Sanders? What number was Barry Sanders? 34. 21-34. Cowboys, ride or die. Does that apply today? Who is Barry Sanders? Nobody knows. So it doesn't really work now. Okay? But it's supposed to go 21-34. Cool, right? Or it goes 1, 2, 3, 4 counterclockwise. If you go negative x and negative y, you wind up in quadrant 3. Yes, so this statement is true. Now maybe if your parents watch this, they'll be like, yeah, good for that guy. Now we have to write the converse. We have to speak it into existence. That's where you switch them. If
If they have two negative coordinates,
then
points are in
perfect. If they have two negative coordinates, then they're in quadrant 3. So I said if 2 points have negative coordinates, then they're in quadrant 3. So if they have two negative coordinates, are they in quadrant 3? Yes, true. Hooray! Achievement unlocked. Now what do we get the opportunity to do? More math. Yay! So now we have to write that as a biconditional statement. There's two types of people. People that go to this statement up here and try and write it. We'll call this person number 1. Or people that go right here and try and write it. We'll call that people number 2. What type of person are you? A 1 or a 2? You're a 1 person? I'm a 2 person. Go ahead, give me a shot. What do you got for a biconditional? See it? You see-
points in quadrant 3. Oh gosh. Oh, I got it. No. Points in quadrant 3 if and only if have two negative coordinates.
English, what? Points in quadrant 3 if and only if
I
two.
don't know, I'm trying.
I get it, right? What, are you a one person or a two person?
2.
You're a two person? Go ahead. What you got?
Points are on quadrant 3 if and only if they have 2 negative.
And here's what he did. I guarantee he did this. I don't need this anymore. I don't need this anymore. All I need is this. Points are in quadrant 3 if and only if they have 2 negative coordinates. You get rid of the if, you get rid of the then, and you add an if and only if between them. And it works both ways. Like Alicia, I don't need you anymore. But I do need one of these. 2 points have negative coordinates, if and only if they're in quadrant 3. It makes sense in English. It's hard to do it from this one. It's easy to do it here. And here's my answer, hidden behind this box. Whoa. Points are in quadrant 3, if and only if they have 2 negative coordinates. So I like to use one of my statements and erase the if, erase the then, and add the if. On. Make sense? We're going to speak this next one into existence, and then we're going to wrap it up for the day. Hey, thank you. I already wrote the first one for you. That is the conditional statement. If 2 segments have the same length, they're congruent. True or false?
True.
Achievement unlocked. Now what?
If they are congruent, the 2 segments have the same length.
Perfect. If they are congruent, then 2 segments have the same length. Another achievement unlocked.
2 segments are congruent if and only if they have the same length.
And I saw your eyeballs reading off of this one right here. She said, 2 segments are congruent if and only if they have the same length. Perfect. Look at me teaching you guys things. Where's the box? 2 segments are congruent if and only if. That's a lot easier to do, isn't it? Yay.
Yeah, but it's like, it sounded weird to say.
It sounds weird to say. Now, do you have to write any statements on your test? No, you just have to pick them off of a multiple choice list. So you're just reading for correctness and English language, because it makes sense in English. So, all I have for you